y is equal to a plus b1 x1, and there is one more model, y is equal to a plus b1 x1 plus b2 x2. So I want to basically evaluate, like, which model is better, whether the first model is better or the second model is better. So naturally I would like to go for the model where the error is lower. So based on the error, based on evaluating error, I'm going to find out like which model is the better fit. So that's where I'm going to use this AIC and BIC. Okay, see, formally to find out which model will work, I'm supposed to use F-test, but otherwise AIC BIC model also can be used. So let me speak about this AIC and BIC. So basically this is an estimator of prediction error. Okay, we are predicting, right? Predicting error, and it is an estimator. Okay, so AIC stands for Akaike's information criterion. That's the long form. Okay, now this is, as I said, the intention is to evaluate the quality of model fit, and it is an estimator of prediction error. Okay, so estimator of prediction error through SSE. SSE is sum of the squared error. I have discussed about this in another video called ANOVA table. In case if you are not sure about SSE, please watch that one. So SSE stands for sum of the squared error. Okay, now since we are estimating error, lower is better here. Lower is better. So I will be calculating the AIC for first model. I will be calculating the AIC for the second model. Okay, so that means for the same dependent variable, I am calculating the competing models. I'm calculating the competing models for the same dependent variable. So out of this, both the models, wherever the AIC is lower, I will be picking that one, right? So so that's what AIC is. So AIC, the goal of AIC is to have a better forecast. Okay, better forecast. So it is basically wherever the error is lower, that will give you the better forecast. So how do I calculate this error? So AIC is equal to, the formula is n into ln, that is log normal, SSE divided by n plus 2k plus 1. Okay, so this k is number of independent variable and SSE is sum of the squared error. Okay, and so if we try to understand this one, it has been divided into two parts, this formula. Okay, now SSE by n is giving you the kind of mean error, and then when we do ln, it is converting basically that into a rate. Okay, multiplied by n. So that means at what rate error is happening in this model, and then that has been exaggerated with twice of the total variable, because k will tell you independent variable and 1 is intercept. So this will become total variables into into 2. So into 2, it is exaggerating the error. Okay, now whatever number you get here, this you will calculate for both the models. For the first one, taking its SSE, and for the second one, taking its SSE, and then whichever is the lower one, that, okay, so amongst this, whichever is the lower one, okay, first or second, whichever is the lower one, that model will give you a better forecast. It will give you a better forecast. Okay, so that is the use of AIC. BIC also is of similar type only. It stands for Bayesian Bayesian information criteria. Bayesian information criteria. Now here the intention is not to forecast, but then to find the better goodness of fit. Okay, if the model is fitting now properly or not. So here the goal is The goal is to find the better goodness of fit. So goodness of fit, as in basically this is about the present. This is about the present, whether the model is fitting properly or not. Whereas AIC is about forecasting. Okay, this is about whether if it will forecast it better or not, and BIC is if the model is fitting now correctly or not. Okay, now for BIC the formula is n into ln SSE divided by n plus ln into ln of n, that is log normal of n, into k plus 1. Okay, now this is the formula. Now here also you will find out the BIC for the first model, you will find out the BIC for the second model, and then whichever is the lower, you will select that one for finding the better goodness of fit. Okay, and here k, again it indicates the number of independent variable. Now if you analyze the formula, see this first part is just as the first part of AIC. The first part of BIC is just as the first part of AIC. So both are talking to us about the error. Now the second part, if you see, there is a slight difference between AIC and BIC. In AIC, we are scaling up the error by twice the total variable. In BIC also we are scaling up the error. Now when you are scaling up the error, the way we are scaling, that is slightly different from AIC. Over here we are taking the total variable, but then after that we are taking the log normal of n. Okay, and that log normal is multiplied with the total variable. Now when we take log normal of n, so generally what will happen is this log normal of n will be more than 2. So now here you see it is 2 in AIC, whereas in BIC you will get more than 2. So basically you are scaling it with more than 2, bigger number, bigger error. Okay, because we are finding right now if the model is good enough or not. So we are being more strict here. So we want something bigger than 2. 2 is for AIC. So because we want bigger than 2, we are taking ln of n. So ln of n, say for example, if you take ln of 50, ln of 100, you will get more than 2. So that's how bigger error we are trying to show over here, and that's how we are trying to find the goodness. So this is like a penalty, higher penalty we are doing to find out the better goodness of fit. Okay, fine. Thank you so much. This is what AIC and BIC is all about. Thank you.